Can you see my my whiteboard?
Whiteboard. Yes, sir.
An examination paper consists of 8 questions, of which one is geometric distribution and one is binomial distribution. If the 8 questions are arranged in random order, find the probability that the question on geometric distribution is next to the what? To the question on binomial distribution. So what do you do?
I'm just getting my notebook and stuff out, so 2 seconds. Okay, so they're saying if the 8 questions are arranged in random order, the probability that the geometric distribution is next to the question on the binomial distribution. Geometric distribution of 7 marks each. Can you just go through the first one with me, sir? Can you just go through the first one with me again, sir, please? Through the first question.
That's not difficult. So whatever the probability that they're asking is going to be over the total possible what? Total possible.
Yeah.
So what's the total possible if there are 8 questions? Let's say they were all different.
8 questions.
If they were all different, it's 8 what? 8 factorial. If they were all different questions. Do you agree?
Yes, sir.
Now we have the geometric and the binomial always sticking together. Remember what you said the other day? Always sticking together here. Then you've got the 6 other questions here. So it means this you treat that as 1. So it's no longer 8, it's 7. So you're saying 7 factorial like this. Multiply by, because these 2 here, it means I can start with the G or they can permit themselves 2 like this, divided by 8 factorial. That's how I calculate that probability. Divided by the total possible arrangement.
Okay, so I understand. So we have the 8 questions. So that's the denominator for the 8 because there's 8 possible.
Yes. If they're all different, yes.
Yeah, and
that's
then
your space, which is 8 factorial.
So here you circled here. What's that? GB.
Otherwise, what we are saying is the probability of what they've asked is the probability of geometric always next to divided by the probability of all the total possible outcome, which is this. By GB, what I'm meaning is geometric and binomial. So I'm saying they are always sticking together. Okay. It's like this. Remember last time we said the word hello. How many times what I gave you in your notes? How many times can the word hello be arranged if the L's are always together? And we said we treat this as 1. Then we can think of the other letters like this here, which are 3. So we're saying 1, 2, 3, 4. So it's 4 factorial. But this time I don't multiply by 2 because these L's are the same. If they were different, then it would be multiplied by 2 factorial. Clear?
Yes, sir.
Making sense? For example, if I pick this word here randomly, and I say, how many ways can I rearrange this way if the R and N are always together? So I treat that as 1 because it's always moving.
It's 1, yeah. So
then I say A.
So then it would be A D
N
D O M.
Sorry, A D O M, like what you're saying. So 1, 2, 3, 4, 5. Then I say 5 factorial multiply by Y because these 2 can change position twice, like this. That's what you're talking about here.
Okay.
Going back to that.
So
because I've got a geometric and a binomial always sticking together.
Yes.
So it's 2 of them here. Then I'm all left with 6 other questions. So because it's 6 and this you're treating as 1, that's where the 7 factorial is coming from. Multiply by this can permit themselves 2 twice.
Okay. Okay.
And what do you get there?
Okay.
You use your calculator.
So you don't have a calculator with you because I'm working away from home, so I don't have my calculator, unfortunately.
Yo. I don't have a
So,
calculator. I thought you guys come.
okay, wait, let me see. No, sorry, I'm just working from the office today, so let me just quickly see if I can find one. Give me 2 seconds.
Okay.
Okay, someone's trying to find one now, so I'll have one soon. Okay, well, so we can just presume that when do we need this answer for the third question?
Yeah, I'm saying there are all the other questions we actually need calculations.
Yeah, I know. I'm just trying. Someone's looking for one quickly now.
Oh, okay. Anyway, 8
Can we do
factorial
the-
means
can we
8
do the
times
next one
whatever
so far?
times. Yeah, even the next one we are going to. Okay, I get your point. The better you find the calculator was even the next one. Okay, we'll
Yeah.
analyze and we'll come back. But I'm saying, so now we have 4 questions now, including one on geometric. We have 4 questions, comma, including one on the geometric distributions. Are worth how many marks? 7 marks each. And the remaining 4 questions, including what? One on binomial, are worth what? 9 marks each. So you now have 2 sections. The 7 mark questions are the first 4 questions on the paper, but are arranged in random order. Then the 9 mark questions are the last 4, and they are arranged in random order. Clear?
Okay.
Find the probability.
So
yes.
Yeah.
That the questions on the geometric distribution and the question on the binomial are next to one another. Clear?
Okay.
So before you answer
so
that,
we have,
yes, you think of sections. We have got 2 sections.
Yeah.
Section A and
Yes.
section what? And section B.
And B.
This is a 9 mark section. This is a 7 mark. Is that correct? No, 7 mark here. And this is a 9 mark what? 9 mark question. Do you agree? 7 mark, 9 mark, followed by the 9 mark question. Now we have 4 questions here. So you have to think of mechanism here before you rush to formulas. So we've got 4 questions here, we've got 4 questions. Now, what are they saying? They're saying the question on the geometric should be next to what? To the binomial. So they are in different sections. The only way they can be facing each other is if I have the geometry question as the last question here. Do you agree? And I have the binomial on this here. Read the question again. You see why. Otherwise, they can never be next to each other.
Okay, so you've written it under section A. What's that, 9, sir?
No, that's G for geometric.
Okay.
They said
so G and
including one question, yes. One question on geometric, 7 marks. So I'm saying if it's any other way, it can never be next to the. If I place it on here, then it can. Then I'll have another question here, so it won't be next to the binomial. Is that making sense?
Yes, sir.
Which means here, for example, I can have question 1, question 2, as an example, question 3, then geometric binomial. So maybe question 6, question 7, and question 8, something like that. Clear?
Yes.
So now, in terms of the, when I've got sections like this, I can, if I say 8 factorial, that's wrong. I'm saying the total possible, if all the questions are different. Because I've got section A and I have section, it means this here, if they're all different, it's 4 factorial. Clear? Multiply by the other section, if they're all different, it's 4. It's 4 factorial. Clear?
Yes, sir.
So now it means that in terms of now, my what I'm dividing, my total space is 4 factorial multiplied by not 8 factorial, because there are 2 different sections here. Clear?
Yes, sir.
Now let's think of now, this is not moving, it's static. So if it's not moving, I consider the other 3 can permit themselves 3 what? 3 factorial, because there are 3 different questions.
Okay.
Multiply by this time, this again is fixed. So these 3 can permit themselves 3 factorial.
Yes. Okay, so I just stop you there just to make sure I'm following. So we've got section. Can you scroll up a little bit just so I can see the question? So there's 4. So just so I understand, we got the four questions under section A and section B. Section A is 7 marks, section B is 9 marks. So we split those two in A and B. The geometric is fixed and the binomial is also fixed. So then under section A, we'll have question 1, 2, and 3. And those are the four questions. So underneath we've got 4 questions in both section A and B, which that's the denominator. So it's 4 times 4.
Yeah, it's 4 factorial. Yes, the reason why it's 4 factorial is this. If they're all different, we will treat them 4 factorial ways. Yes.
Yeah. And then the geometric is fixed, so we can't multiply that. So we got question 1, 2, and 3, which can move around. So we've got 3 factorial times 3 factorial.
Yes.
Okay. Okay. I've got a calculator now, by the way, so.
Okay, so you can calculate that.
Yeah. So I'm just trying to find where the factorial is.
What calculator is that? Casio or Sharp?
The Casio, sir.
Oh, okay. Casio.
I think I've got to go into mode here, and then into. I can't see the factorial, so.
It's there on your. We said Casio.
Yeah, Casio.
Hold on.
Oh wait, I think I got it. Is it? Hold on. Yeah, I've got it, sir. So it's 3 times 3 fac. Oh no, man. Over. So it's 3 factorial times 3 factorial over 4 factorial times 4. So here it's giving us 1/16 or 0.0625.
No, give it as a fraction. What did you do? Did you do factorial? You're supposed to get to a fraction here. 3 factorial.
I've got here 3 factorial. It looks like an exclamation mark. 3 factorial times 3 factorial over. Yeah, over 4 factorial times 4 factorial.
You're supposed to get a fraction.
And it gives you, it says 1/16.
1/16.
Or if you.
Oh, okay, that's fine.
1/16. Yeah.
Yeah. Better leave it when you're doing this fraction. Perfect answers.
Okay.
Okay.
Yes, sir. Okay.
Happy?
Good. Yes, sir. Happy.
Now the last one is the tricky one.
Okay, so
the questions on what? Last part. The question on the geometric and the question on the binomial are separated by at least how many spaces?
2 other questions. Okay, so we got A and B again.
Let's do 1. Yes, 1, 2, 3, 4. Let's do 1, 2, 3, 4. The positions. Then 1, 2, 3, 4. So 1, 2, 3, 4. So now remember, but the fact, even if they are separated by, it remains that the geometric is always on the section A, yeah? The binomial on section B. Yeah? So let's say the geometric remained on this here. Follow me. So if the geometric remained on this, can we put the binomial here to be wrong? They are separated by at least means 2 or more other questions. Huh? Clear?
Yes, sir.
So which means I can't even put it on this position here. In fact, let me do 5 so that we see 6, 7, 8. Now I can't put it on this here because there's no space. If I put it on position 6, it's differing by question 1. We need at least, so it can only be here. Can you see that? The binomial.
Yes, sir.
So it means I've got position 4 and position what? In position 5. Huh? So in position 8.
Yes.
In 4, then 5 we left it, 6 we left it. Oh, how did I count it? 7, sorry. So position 4 and position 7. Huh? Clear?
Yes, sir.
Because if I have 4 here and I put it on 6, it's a difference of 1. Said at least 2 other questions. Then I can also have this and it comes on this here, which is position what? Position 8. Can you see that?
Okay. Yes, sir.
Then I can, if I now move it to position 3. So what do we have now? We now have position 3 and what? If it's now on 3 here, we skip this. Then we start at 6. Huh? So 3 and 6, 3 and 7, you see that? And 3 and what? Position 3 and 8. Huh?
Okay.
Then we can now put it on position 2. 1, 2. So this set that we can start at better. So I have 2 and 5. Was see position 2 spaces. So 2 and 6, 2 and 7, 2 and 8. Happy?
Yes, sir.
Then if I have it on position 1, it can never be on this. It has to start on this. So it will be 1 and 5. Huh?
Yes.
1 and 6, 1 and 7, and 1 and 8. How many combinations is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did you mess up something? Wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Correct. So 13. It's 13. Huh?
Okay.
Now, 13 times what? So remember there are 2 different sections. So 13 times, that doesn't change the position. The fact that is there, it means all the other 3 questions still permit themselves 3 what? Factorial. Then the other side is the same. It doesn't matter the position of the binomial. The other one is simply 3 what? 3 factorial. Clear?
Yeah.
But it's happening 13 times. Divided by, if it's section A and section B, we said 4 factorial multiplied by 4 factorial, like that.
Okay. Okay, so okay, so this one's confusing me a little bit. This one's confusing me a little bit. The steps. I mean, I'll calculate it, but the steps are just how we got the answer. So it's 13 times 3 factorial times 3 factorial over 4 factorial times 4. So this equals 13 over 16.
Okay. Yes.
Okay, this is confusing me a little bit how we got to the final answer.
How we got the final answer?
Yeah, the steps, the steps we went through. So
okay, I get your point. Let's go back here. What is the question saying? We still have got 2 sections. Section A and section B. Clear? But the only difference here, look at this. So I've got 4 questions here. That's what I meant. And I've got 4 questions here. So I was just saying this is question 1, question 2, question 3, question 4. Question 5, question 6, question 7, question 8.
Okay.
Although we are treating them as separate. That's what I was simply saying. So then I was saying, if they are separated by at least 2 other questions, if the question, the geometric is on position 4, I can never have binomial on this because it means they are not separated by any other question. If I have the binomial on question 6 here, it's 1 space. It needs 2 or more. At least means greater than or equal to 2. So it means the binomial can only start on question 7. So that's why I said position 7 and position what? 8. Clear?
Okay.
But now these other 3 questions here can permit themselves 3 factorial. And this question and this question can permit, that's why I was saying 3 times 3 factorial. That's where I was coming to. So it's the number of how many times can we do that. Now we can also have, if it remains on position 4, we can now have the binomial on position 8 to be separated by 3. That's what I meant, like that.
Yes.
Now I have 2 cases.
Okay.
Then I changed the position of the geometric to be on position what? On position 3. So if it's now on position 3, I can't have, can I have it on position 5? No, it will be separated by 1. So it means I can now start at 6, because it will be separated by 4 and 5. So it's 3.
Okay.
Then I can have 3, 7, because it will be separated by 4. Then I can have 3, 8. That's what I meant on position 3. Then now I can go to, if I now have that question on position 2, separated by 2, so straight away I can start at position 1.
Position 8.
I can start, no, look at this. I can start binomial on position 5, because it will be separated by this and that. So it's 2 what? 5. Follow? 2.
Yes.
2, 7, and 2, 8. Having it on 2 and on the last one. And now I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So far I've got 9. Huh? Clear? Then I can have it, the geometric on position 1. I can't have the remember the binomial should always remain. Otherwise, if it was shifting to be in section B, I will have the binomial here. It's impossible to have the binomial here because it's in a different section. Clear?
Yes.
Which means although we have 3 spaces here, the binomial can only start on position 5, because it's a different section.
Yes.
So that's why I had 1, 5, then 1, 6, 1, 7, and 1, 8. And this is 4 here, 1, 2, 3, 4, plus 9, 13. That's where I was getting the 13 from. Then I was saying, I showed you that each time we do that, is 3 factorial multiplied by 3 what? Factorial for the other questions. Huh? Divided by section A, they were different 4 factorial, multiplied by 4 what? Factorial.
Yes. Okay. So this. Okay. 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 I think I'm understanding now.
Yeah, understanding now.
Yes. It isn't possible to find another one like this, or another question like this, like similar to this.
I think we'll find it. Don't worry.
Okay.
As we go along, I think there should be another one more similar. Remember. Now look at this here. So sometimes when you see a question, you have to know, is it arrangement, is it permutations or combinations? Now a committee of 7 people is to be chosen at random from 18 volunteers. In how many different ways can the committee be chosen? So what do you do? 2 marks for free? Is it permutations or combinations?
we on which question you answered? 2A.
Yes.
2-1.
So I'm saying, is it permutations or combinations?
This is combinations.
Combinations. Yeah? Combinations. Yeah? We're selecting combinations. So from a commit, so it's a combination. So it means 18 choose what? We're doing it the other day. 18 choose 7. From a committee,
Okay.
from 18, you're choosing 7.
You're choosing 7, yes.
Yeah. So what do you get? 18 choose 7.
Wait, so is this do you want to 18. What do you want me to say? 18 over 7, or what do you want? And how many different ways can? Okay, well, there's 7. Okay, so it'll be. Okay, well, so they're the committee of 7, so it's going to be. People is to be chosen.
Use your
from
calculator, yeah. See,
from that.
it is that see the 18. Your calculator. Use 7.
See, can't find a C.
On your cassette.
Oh, wait, I got it. So it's 18. That's not possible. It's saying 31,824.
What's the answer?
It says here, so 18C7, and it's giving 31,824.
That's correct.
Really? Okay.
Yeah.
Okay.
Cleo, you said what's our answer? 30?
31,824.
Okay. Now let's go to the
31.
next one. Yes.
Okay.
Is that correct? What I wrote?
Consist.
Okay. Now,
Consist.
yes.
Consists of 2 people from Gloucester, 2 people from here. Okay, so it's 18 volunteers consist of 5 people. Okay, so it's 5 people from Gloucester, and then there's 6 people.
Probability. So we're going to divide by this total number of combinations.
Yeah.
So, but do you hear what do you do the first part? So 2 people from this here, what do you do?
So would you say 2 to 31,824 divided by?
No. Don't complicate. Remember, we're talking of combinations here. How many people are we choosing? From how many?
Oh, 2. So 2 from 5.
So it's 5. Choose 2 from Gloucester.
Yeah. So
multiply
5
by
2.
From Hayford, how many? 2 again. We are choosing from what? From 6.
From 6.
Multiply by, we are choosing 3 here from Oyster, like this. Divided by the total possible, which is 31824. Or you can say 18 choose 7 if you want.
Okay, so it's 5 choose 2 times 6 choose 2 times 7 choose 3 divided by 31,824, which gives you do you want a fraction form or decimal form, sir? Fraction form will be 875 over 5,304.
Correct. Now, Exactly how many people the next time?
Include exactly 5 people from who's
It means the 2 others are from Leicester and Hayford. Yeah? Clear? Because the committee has to have 7 people. Clear?
Yes, sir.
So it means from Oyster 7, choose 5. Multiply by, now how many, if we add these 2 towns here, how many people do we have?
We add
5
2
plus
there, so
that,
that's 5 and 6, which is 11. sir.
11. So from 11, we are choosing what? 2. Divided by the total possible.
Okay, so seven, choose 5 times over 31,824, which gives you 385 over 10,608.
Okay. Interesting.
Okay, so I just want to make just see how just to make sure I know what how you got this, how you. So we including exactly 5 people from Worcester. I don't know how to say that word. So at first, it was 2 people from Gloucester, so that one. Which now it's.
So go back here. Your committee should always have how many?
7 people.
Yes. So if we are saying exactly 5, it means the other 2 are from those 2 other cities combined. That's why you said 11.
Yes. So it's.
Clear?
Wait, but if you add the other 2 people from the Hereford, okay, so that's 7.
Yeah, 7. Committees always have 7.
Wait, no, yeah, it's. Okay, so I understand the first part. So it consists 2 people from the Gloucestershire, and you add 5, which then I get it's 7. No. Sorry, no. We're choosing 7 from 5.
We are choosing 5 from 7.
Okay, no. So I get it now. Okay, sorry, I get it now. So
Clear?
yes, sir.
Now the last one, which is the easiest, or maybe can be tricky, not difficult. How many cities do we have again? 3 cities.
3, sir.
You've got, I'll use letters A, G, H, W. So I have 5 people from this city. I have 6 people from this city. I have 7 people from this city. So let's work out possible probabilities or possible. Now look at this. We want at least what? Which means every town should have at least 2 people. Huh? Do you agree?
These 2 people.
But we need 7.
And we need a committee of 7.
So we can have 2 from this city, 2 from this city, and 3 from this city. We can't have 4 from any city, because if we have 4 from any city, then we can't have 2. Clear?
Yeah. Yes. Sir.
So then it means I can also have 3 from this, 2 like this. I can have 2, 3, 2. Happy?
Yes.
From what I've just said here. So now what it means in terms of what we have written here. So let's look at the first, the one on top. So from 5, we are choosing what? 5, we are choosing 2. Huh?
Choosing 2.
Multiply by, from 6, we are choosing 2. Multiply by, from 7, we are choosing 3.
Yes.
Plus, let's look at the next one. From 5, we are choosing 3. Multiply by, from 6, we are choosing 2. Multiply by from 7, we are choosing what? 2. Follow? Plus the last one. From 5, we are choosing 2. Multiply by from 6, we are choosing 3. Multiply by from 7, we are choosing 2. All divided by 31824.
Okay, so basically what we're saying here, so we can have, so we got the first equation, I guess I'm gonna call it the first equation. It's the at least 2 people. So we're gonna go, we're choosing 5 from 2, 6 from then, so 5 from 2 times 6 from 2 times 7 from 3, and then
the way you're
we're gonna,
saying it is not 7, it's 2 from 5 people in that term.
yeah, so we're taking 2 from 5, and then we times 2 from
2 to
6
6
times
3 from 7.
times 3 from 7,
Yeah,
and then we're going
plus,
back to the
yes,
original. Then we're going plus 3. We're going to the second
Yes.
line, which is 3 from 5
Mhm.
times. Then we're going 2 from 6 times 2 from 7, and then we're going again. So you basically
Plus,
have to
yes.
use all 3 lines, all 3
Mhm.
lines over
Yes.
the. Okay.
Yes.
I've got the just worked out. So it's 5 from 2 from 5. Cool. So it's 2 times 6, 2, 7. 3 plus. Okay. So plus 5. 3 times 6 times from 2 plus 5 from 2 times 6 from 3 times over, and then 31,824. It gives you 175 over 442, 175 over 442.
Okay, are we together?
Yes, sir. So it's 10 past 4. Can we just take our 10 minutes now quickly and then carry on?
Yes, sir.
Perfect. See you back now, sir.
Okay.
Yeah, I'm back, sir. So you there? So so you there?
Hi.
Yes, so I'm back.
Okay. So each of the 7 letters in the word divided is printed on a separate card. The cards are arranged in a row. How many different arrangements of letters are possible? Is that permutations or combinations?
This is permutation, sir.
Permutations. How many different arrangements? So what do you do? 3 marks.
Okay, so we've got here and divided. There's 1, 2, 3, 4, 5, 6, 7 different letters.
Mhm.
Oh wait, so there's 7 different letters, but there's there's 3 D's and 2 I's.
Mhm.
So won't we say how many D's did we say? There's 3 times 2 times, and then over 7. So 1 over 210, sir.
What do you do first? If
I've
they're
got
all,
here, so
they were all 7, what do I write?
you've got 7, sir.
No, we can't say 7. Huh? We talked about, I remember, I'm forgetting here when we did that even in notes. When we said we've got these 3 here, we can't say 3. If they were all different, it's 3 factorial. 3 times 2 times 1.
Yes.
So there we can't just
Yes.
say 7. It's 7 factorial.
Yeah, factorial. Yeah.
Yeah, not just 7. 7 factorial.
Yeah,
If
sorry,
they were
I've
all
got, that's what I've got.
Okay. Divided by, clear?
Yes.
Because now we have repetitions, they reduce what? Permutations.
Oh, sorry, I did the wrong way. I did the wrong way around. So I said so we've got 3 D's. So I said 3 factorial times, and then there's 2 I's, 2 factorial. So I did the wrong way around. So yeah, so it'll, yeah.
Because this is not probability. See, it says in how many different arrangements can these letters? So it's the number of possible. We're saying when all they're all different 7. But now what we check what's reducing the permutations.
Yes.
It's 3 D's, 3 factorial times 2 I's, 2 factorial.
Yeah. Yes. So I've got 7 factorial divided by 3 factorial times 2 factorial.
And what do you get?
That gives you 420. So
Correct.
yeah, so I did the right thing, just the wrong order. So
Now the next part. In how many arrangements are all the 3 D's you see always what? Always together. The D, the D, the D. Always to. Then I can have I, follow me. I can have V, I can have I, and I can have E. Do you agree?
yes.
Then this you treat this as 1, 2, 3, 4, 5. So you've got 5. So now I say 5 what? Factorial. Clear?
Yeah.
But I don't multiply by the 3 here because these D's are the same. Clear?
Yes.
So I don't multiply. If there were the different letters, I multiply. Divided by there is an I here, there's an I. It reduces my what? My permutation.
Yeah. So yeah, becomes 2 factorial, and then there's a V and an E. Yeah. So it's 5 factorial divided by 2 factorial, which gives you 60.
All together?
Yes, sir.
No, the last one is a trigger. The 7 cards are now shuffled. 2 cards selected at random without replacement. Find the probability that at least one of these cards is a what? At least clear, which means, look at this. I want to show you something. I can have card A, card 1 here, and card 2. So I can have a D here, read at least one of them, a D and not a D. Do you agree? I can have not a D here, and I can have a D here. Or because it means at least it's in 1 or more, I can have a D and a D.
Yes.
Also card 1, card 2. Is that making sense?
Yes.
Now let's think of the probability here. If I'm having a D, I'm picking from 3 what? From 3 D's, 3 over 7. Clear? Multiply by, if it's not a D here, remember I've picked without replacing. I'm no longer, so I've picked 1 card. I'm left with 6 cards. Like this. Clear?
Yes, sir.
Now, remember saying not a D. So if I've picked 1 D, like this, how many cards are not a D from what's left here? 1.
1,
3,
2,
4.
3.
No, 1.
Sorry, 4. Sorry. 1, 2, 3, 4. Got it, yeah?
Like this. Clear?
Okay.
Plus,
Yes.
Now let's go to the next line. If it's not a D, how many are not Ds? 1, 2, 3, 4. So 4 over what? 4 over 7 for the first time. Multiply it. Now I've picked one that is not a D. I'm left with 6 cards. Clear?
Yes.
But I haven't picked a D the second time. So I still have the 3 Ds that I'm picking from like this. Plus,
Yes.
if it's the first D is 3 from 3 Ds over 7, multiply by now the second one is a D again. I'm left with 6 cards, but it's no longer from 3 because I've picked 1 D. It's from 2 Ds like this.
Okay. Okay, do you want me to put, okay, so it's, wait, so that's 3 over 7 times 4 over 6 plus, so okay. Plus 4. 6 plus 7 times, which gives you 5 over 7. So is that correct, sir?
Yep.
Okay.
Now, the digits 1, 2, 3, 4, 5 can be arranged in random order to form a 5-digit number. 5-digit number. I see 1, 2, 3, 4, 5, 5-digit number. How many different 5-digit numbers are formed? 1 mark. What do you think?
Okay, so they want a 5-digit number. So I keep forgetting the name of the exclamation mark point. You know what I'm talking about?
Factorial.
The 5. It'll be
Factorial.
Sorry. So it'll be 5 factorial. And then there's And there's 5 digits that can form a 5-different number.
So what's the answer?
So I'm just trying to figure out how many different 5-digit numbers can be formed. So there's digits 1, 2, 3, 4, and 5, and they want how many times it can form a 5-digit number. So to put in my calculator, what would I put in? I'd put 5 factorial.
Yeah, those are the arrangements. Why complicated? There is no repetition here. 1, 2, 3, 4. These are 4, 5 different numbers. So simplify.
Okay, well, so if I put 5 factorial gives you 120.
Yeah, that's it.
Oh,
because those numbers can be arranged. They can permit themselves 5 factorial ways to form whatever.
Yes.
Because they are 5, they will always form a 5-digit number. They're not. If there were 6, these are 5 numbers.
Yes.
And they are all different. So nothing will reduce permutation. So I don't know why you were, because you have to understand what
Okay,
you're doing.
yeah, so I don't know why I was
like if I have A, B, C,
confusing
D.
myself.
So that's what we are talking about here. Find the probability now that the 5-digit number is an what? Is an odd number. So it means we are going to divide by what? by 120. Yeah? Is that making sense? By
Yes.
clear, but it's a 5-digit number. So odd number, what does that mean? If it's an odd number, it means the number ends with what? With 1. Do you agree?
It'll end with a 1. Yeah, 1.
You end with a 3.
1, 3,
You
or
end
and
with
5.
a what? With a 5.
5.
So look at this. The 1 is fixed, which means if the 1
Yes.
is fixed, I can have the other 4 numbers permitting themselves 4 factorial. Clear?
Yes.
If I can have 3, the other 4 numbers can permit themselves 4 factorial. This is fixed here. If I can have 5, the other can permit 4 factorial.
Yes.
So it means it's simply 3 multiplied by 4 factorial, or we can say 4 factorial plus 4 factorial, just the same way, divided by 120.
Okay. Which gives you 3/5, or
Yeah.
Okay.
Yeah.
Yes.
Now, the next part. Less than what? 23,000.
23,000.
So think of a 5-digit here. If it's less than 23,000, less than 23,000 from a 5-digit number.
Mm.
What does that mean? It's a 5-digit number. We want it to be less than 23,000. We can't have 2, 3 here.
Well,
because
okay,
we've got
we
4,
can't.
5. Clear? If we have 2,
Yeah.
3, 23,000, it will be above that. So it has to be, it's
Yeah,
not
so
possible.
it has.
Yes.
Yes.
So it has to start with
So
what?
1 and 2 are fixed.
1
so it has
and
to
2
start
like
with 1
this.
or 2.
Yes. So that is 12,000 and
Yeah.
something. 1 and what? 1 and 3. Fixed.
1
So
and
that is
3,
13,000
1
and
and
something.
4.
1 and 4.
Yeah. 1,
So that is what? 14,000 and something. 1 and 5. So that
1
is
and 5.
15,000 and something. Is there anything
Yes.
else besides starting with those? Is there any other combination that we are not thinking of?
Unless it's 1 and 1.
No, we don't have. We use the numbers already.
Okay, yeah. So then other combinations could be
Can we start with 4? Is it possible? It's not possible. Was it before to 1,000 or 42? It's not possible. Can we start with 5? It's not possible. Can you see that? Starting with 3, is it possible? It's not possible again. Do you agree? Heavy? Either. If I lost you, what happened to your network? I can't hear you. Hi.
So I'm back. I got kicked out.
So now those are the only combinations are from this. Now this is fixed, like what you're saying. This is fixed.
Yes.
This is fixed. So if it's fixed here, I can only have 3 other numbers. 3 factorial.
Yes.
Then 3 factorial here. 3 factorial. 3 factorial. So it's 1, 2, 3, 4. So 4 multiplied by 3 factorial divided by 120.
Okay. Okay, I understand. So I understand also. I understand. Gives you 1/5.
Maybe.
Yes, sir. How many different teams of 7 people can be chosen?
Give you 2 minutes to do those 2 questions, which are easy.
With regard to how many different teams of 7 people can be chosen with regard to order of a squad of team. Presuming I've done this correctly, I've said 15 chosen 7, or 15 choose 7, because you're choosing 7 from a squad of 15, which gives you 6,435. So are you there? So are you there? The squad consists of 6 forwards and 9 defenders. How many teams containing 3 forwards and 3 defenders can be chosen? So are you there? So So are you there? So are you there?
Are you done?
Yes, sir.
The first one?
So the first one, I'm presuming, so you got 7 people that can be chosen from a squad of 15. So I said, so 15 chosen 7, which gives you 6,435.
Okay. Next one.
And then for B, I think this is what you do. So the squad originally consists of 6 forwards and 9 defenders. And now they're asking for 3 forwards and 4 defenders. So now they're saying 6. So I said 6 chosen 3, which gives you 20. And then
Multiply.
6. Yeah, so 6. 6 chosen 3. Multiplied 9 chosen 4, which gives you 2,520.
Basic question. No. And then
So the letters A, B, C, D, and E are arranged in a
that.
straight line. How many different arrangements are possible? Okay, well, so there's 5 arrangements. So you're just going to say 120. So.
Next one.
And then how many of these arrangements are the letters A and B next to each other? So now we're going to say that A and B are 1. So it'll be A
Mhm.
and B is 1. And then there's, so then that means we have C, D, and E.
Mhm.
So would you, then you would say, is it? It's so I always get confused. Now I mix myself up. So A and B are now considered as one
Mhm.
factorial, and then there's 3 factorial remaining. So that means it'll be 5 over divided by OH factorial.
Why are you saying 5? Where is that coming from?
Oh wait, sorry. 3
Sorry, sorry,
factorial because it's
There's nothing to do with 3
yeah.
factorial. It's 1,
So
2, 3, 4. You're saying you're saying it, but you're failing to understand what you're saying. A and B are sticking together. So it's 1, 2,
yeah.
3, 4. You no longer have 5. We have 4 because A and B are always together. So it's 4 factorial. But that's not the answer. Those A and B are different. Clear?
Okay.
So you can swap them 2 times.
I mean 24.
Are we together? Did you understand what I said? I said 4 factorial will be incomplete because A and B are not same letters, they are different. I can have it as AB or I can have it as BA, but still they are sticking together. So they can permit themselves twice. That's what I said last time. No, I can't hear you.
think
It's breaking your.
yes. So it's 4 factorial. Sorry, so it's the answer is 48.
Are we together now?
Yes, sir. So I understand now.
Okay. If the letters A and B, C, D, okay, from the letters A, B, C, D, 2 different letters. Are selected right? It's random. Find the probability that these 2 letters are what?
Probability.
Are A and
A and B.
B. From the 5 letters. 2 are selected at random. Okay. And the probability that these 2 are
So I got kicked off, so I should be better now. So from the letters A, B, C, D, and E, find the probability that the 2 letters that are chosen are A and B. So
if we do the long way, simply means I can have A, B, or I can have B, what? BA.
B,
So A is 1 over, but it's only 1 over 5. Multiply by, now I've chosen 1 unless it's 4. Then B is simply 1B here, like this. Then I can multiply that 2 times. Why? Because the order is the same here. B is 1 over 5 multiplied by 1 over 4. That's why I'm saying times 2 here.
okay. You're saying gives you 1 over 10.
Yeah. Now, this is only similar to almost the first question that you should be able to get correct. And you do that here.
Just Okay, so a test consists of 4 algebra questions, A, B, C, and D, and 4 geometry questions, G, H, I, and J. The examiner plans to arrange all 8 questions in a random order, regardless of topic. Okay, so we've basically got 2 different equations. We've got equation A and B. We have in A, there's four algebra questions in each question. So we have A, B, C, and D, and in B we have G, H, I, and J. So now we need to figure out how many different arrangements are possible between the 8 questions. So that's one. So in A, it'll be 4 factorial, which is 24. There's 24 different arrangements out of A, B, C, and D. And then the arrangements, then it'll be 24 again for G, H, I, and J.
No,
so
that's
there's
not
another
correct.
24. So this.
That's not correct. So read the question again. The examiner plans to what?
Plans to arrange all 8 questions in a random order, regardless of topic.
Yes, which means the section does not matter.
So, so 8 factorial is 40,320.
Yeah, you can't say 4 factorial, it's 8 factorial, because the order does not matter. It's regardless of topic.
Okay. Find the probability that no 2 algebra questions are next to each other and no 2 geometry questions are next to each other.
Interesting.
Okay, okay, now how would we do this, sir?
Just always think of what they're asking. I've got you've got like 1, 2, 3, 4, 5, 6, 7, 8. So your algebra is what? A, B, C, D.
It's 4 algebra.
So I can't have n of these. I'll have algebra, then I'll have geometric. So let me put G here. Clear? Then if I have the next algebra here, then I'll have the next geometric, something like this. Is that making sense?
Yes.
Then if I have
then you'll have C
here, then I'll have here.
And I.
Then if I have
D and J
here, then I'll have J there.
You'll have J there. Yes.
Is that what they say?
Yeah, so they're saying find the probability that no 2 algebra questions are next to each other and no 2 geometry. Okay, so that's the only way that you can. If you mix those up, there will be algebra and geometry next to each other.
Mm-hmm. Is that making sense?
So would that be would I just write that as the answer?
No, that's not the answer. This is just the mechanism that I'm showing you. So from the first here, from the first position, pay attention to what I'm going to say. I'll have 4 possible ways of picking from the geometry. Then now from this here, I'll have 3 possible ways because I've picked 1 geometric. Then from this here, I'll have 2 possible ways. Clear?
Yes.
Then from the last one here, I'll only have 1 possible way, because it's the last one. Then if I go there, so multiply by. If I go there, I'll only have 4 possible ways because I haven't picked any geometric. Then there, I'll have 3 possible ways because I have now 1 geometric position taken. 3. Then there, I'll have 2 possible ways. Then there, I'll have 1 possible way.
Okay.
So what I've actually done there is as good as saying 4 times 3 times 1 is 4 factorial. Multiply by 4 times 3 times 1 is also 4 factorial. Clear? Divided by your 8 factorial here, since there was a random order.
Yes. Okay. which gives you 1/70.
Okay. All right, the next section. Maybe the first question, I won't have time for the other.
Later, the examiner decides the question should be arranged in 2 sections, algebra followed by geometry, with the questions in each section arranged in a random order.
Mhm.
How many different arrangements are possible? So they basically want algebra first, followed by geometry, with the questions in each section arranged in a random order. Well, there's 4 questions in each section, and there's 8 questions in total. So again, won't it just be 8 factorial?
No. If you are saying 8 factorial, I thought this was the number one that you're asking me that can you find another question? So maybe you haven't mastered that. If you are saying, if you say what you are saying, you're actually saying there are no sections. Because if you say 8 factorial, it means there are no sections. It means all the 8%, there are no sections.
Yeah.
Yeah.
So there's 2 sections with 8 questions.
Yeah, section A has got 4 different.
4, and section B
so it's
has
4
got
factorial.
4.
Yes. So it's 4 factorial
Yes.
in section A. Multiplied by the 4 factorial in section B.
This thing gives you 576.
How would you get that then?
Yes, sir.
That's what it means. Because if you say 8
Okay.
factorial, then there's no separation. They're just 8 letters in random or
just
8
8
numbers.
questions.
Yep.
Okay.
Now find the probability that the A and H are next to each other. Just the same way we did that, the A has to be at the end.
Yeah.
And the H has to be at the start, remember? Then we had said
Yes.
the other 3 here factorial, the other 3 factorial here, if you remember that at the geometric end. So it will be 3 factorial multiplied by 3 factorial multiplied by the answer you got here. The possible 5 something. Or 4 factorial multiplied by
I'll calculate very quickly. 4 times
4 factorial.
It's 576. 576.
Yeah, 4 times,
so it's
so maybe you can decide the
which gives you 1/16. So.
Okay, maybe I'm saying you can try now question 8. So maybe I'll send on the AS group. Huh? Question 8.
Yeah, can you put on the group, please?
Yeah. Okay.
Okay. All right, I'll get that done and send it to you, sir.
Okay.
Thank you. Bye-bye.